Hello everyone. Today we have Pre-Calc Lesson 49, the logarithmic function and development of the rules for logarithms. So let's talk about exponentials versus logarithms. The functions are inverses. So we remember we talked a lot about going from exponential form to logarithmic form. And what we need to know about their graphs as well as the equations is they are inverses. Okay, we know that this is the exponential version if we had n equals b to the L, and the logarithmic version would be L equals log base b of n. You need to know how to go back and forth between these two easily. That's how we'll solve several different equations. If we look at their graphs, this is the graph of the exponential, this is the graph of the logarithmic. Exponentials, we know, always go through 0, 1, and the inverse of that, logarithmics, go through 1, 0. And you'll notice they're reflected across the line y equals x, right? If I draw that in both, they're directly reflected across it, which shows us that their graphs are inverses. Now, let's do a quick review of their properties, right? These are the law of logarithms I've told you to memorize. The product rule, if we have the log base b of m times n, then that's the log base b of m plus the log base b of n. If we have the quotient rule, the log base b of m over n, that's the log base b of m minus the log base b of n. And the power rule, if we have x times the log base b of m, then it gives me the log base b of m to the x. All of these can be written in other ways, vice versa. So let's develop one of those laws. I've told you to just take it at face value, but let me show you how they come about. So let's let m equal b to the a and n equal b to the c. Okay, and these are the exponential forms. So if I was to rewrite this, I would say the log base b of m equals a, and the log base b of n equals c. So let's look at the log base b of m times n, right? I can really substitute this and say this is the log base b of b to the a times b to the c, right? M times n, this is what m equals, this is what n equals. And we know properties of exponents. If I have two things of the same base being multiplied, I add their powers. So this becomes the log base b of b to the a plus c. And we know the log base b of b to the anything is that anything, right? Here's a little side note to remember. If we have the log base b to the 3, that's just 3, right? The log base b of b is 1. I'll write that log base b of b is 1. Log base 10 of 10 is 1. Log base math of math is 1. Okay, log that has the same base and same argument is 1. Okay, so here this really just gives me a plus c, and I know that a is the log base b of m and c is the log base b of n. We've developed the product rule. Okay, you can actually do the same thing for all of the different log rules. If you're interested, it's page 339 in my book. In your book, it will be right above your problem set. You can go look at those, but I'm going to give you a shorter lesson so that you can focus on everything else. So you're welcome.